Hey, hello, Chong, and hi, Russ.
Hello.
Good
Hello.
morning, morning, everyone.
Uh,
Good morning.
uh,
How are you folks doing? Sorry I'm late.
Finished.
Yeah,
Yeah, I'm doing okay, thank you. How are you?
really good. Um, Trying to start the day after a long travel yesterday. Came back home really late, so hopefully the 10th coffee will make a difference. Uh, all right, so today the topic is test design kit. I got a last minute note from Bala that he won't be able to make it. I don't know how much progress we can make without him. But I wanted to go around the room and see if you guys have any updates. Um, what news happening in your end of the world? Um, Mark, what's the latest on the 3D blocks and IEEE? How is that coming along?
It's coming along. The latest is that the uh, the leader of that work group, Sandeep, wants us to have a spec that's in good enough shape by the beginning of next year that a technical writer could start working on it. Um, But one part, there's a particular part of the specification having to do with feasibility analysis for the power distribution network and also thermal feasibility analysis. And for that part, Andrew Kahn and I both expressed some concerns because the way the spec was written, it didn't enable transient analysis, and we were um, wondering whether transient analysis should be included. And so we wound up forming a tiger team, what is being called a tiger team. It's a subgroup of the overall work group that's looking into that topic. I'm in charge of that tiger team, and Andrew Kang is the co-leader, and we have 8 other people in it from various groups. And the purpose is to decide, okay, for this early feasibility analysis, is transient analysis within the scope? I mean, should it be within the scope? Um, the TSMC people say this is deliberately meant for some really early analysis before you really have a design. You don't have necessarily a power grid set up yet, for example, but you want to do early analysis to check whether to check feasibility and decide on different stacks and see which one you really want to pursue as an architect, for instance. So is transient analysis relevant in that early stage, or is it really too early for that? That's one question. And then another question is, okay, if we do decide transient analysis is relevant for that early stage, then how should the spec be updated to enable the transient analysis? Because right now, for example, the power distribution network spec is just a resistive, well, it's basically a set of resistive networks for each chiplet. And so obviously, if it's just a resistive network, it won't support transient analysis. And so the question is, what updates should be made to the spec if we decide that transient analysis should be supported? And so that's where we are on that. It's the work group that I'm talking about has just formed recently. We had our second meeting just earlier this week, so it's still pretty new.
Hmm, Okay, that's very interesting. Is the focus on transient power or transient thermal as well?
Right. It's both that we're talking about because
Okay.
the 3D block spec, um, it has three sections to it. There's the sort of core section on the 3D blocks kind of connectivity and physical design. It's the thing that describes the 3D stack, and it describes what information you need on a chiplet to support integrating that chiplet into the stack, things like that. So that's one section. There's a second section on this thermal and power distribution network feasibility analysis. And then there's a third section on they call it the constraints, some sort of constraints. It's the constraints analysis for like design rules associated with the overall system. Um, and so the work group committee says that it's possible that the that that the standard will not include all of that. It's possible that we will in the end recommend that the standard only includes that central the first part, the core connectivity and such, and then the other parts don't become part of the standard initially. That's being left open at this point, but nevertheless, and in fact, that work group, the Tiger team I mentioned, some of the people on the Tiger team say, well, it's kind of early to put this feasibility analysis into the standard. Let's just not put it there. Let's just recommend that it not be included in the standard, at least this first iteration. But the leader of the work group, the leader of the overall IEEE work group says, no, the Tiger team was specifically formed to look at whether we need transient analysis. So the topic about whether the feasibility analysis itself belongs with the standard, that needs to be at the work group level. The Tiger team can't decide that. And so anyway, that's where we are on it.
Yeah. Yeah, my opinion is that this Tiger team, I hope you end up in a place that says, yes, we need transient analysis. But really, transient analysis is all that matters when it comes to power. And thermal is really important once you start putting in the different workload to understand the performance of the system, right? Thermal and power are performance. And performance these days is everything,
Mm-hmm.
right?
So
Yeah.
David, um, do you mind if I kind of consult with you offline about this before our next Tiger team or sometime soon? It might not be before the next meeting, but I don't actually believe that I have your contact info. So outside of these meetings, I'm not sure how to reach you, but
Oh, really? Okay. Yeah, let me put my email in the chat.
okay. That'd be great. And
And
then if you don't mind, I'd like to communicate with you a little bit more about that.
okay. Yeah, sure. What do other people think about transient early planning?
Yeah, David, this is Tony. Yeah, the early feasibility, both thermal and stress, quite honestly, I don't agree that that should be part of the 3D spec, 3D block spec. I think that's more of a design flow issue, and I think it's getting out of really what the original intent of 3D blocks is. It's a design flow issue. So, and all right, if you're going to do thermal and stress, yeah, maybe for early feasibility, you can do very simplistic, models for that, but it's necessary but not sufficient. If you're really going to support it, you need to have a full fidelity model that can go from, back of the napkin swag through sign off, right? And I think once you go down that path, what's the point of just having, an early feasibility thing? It just doesn't make sense to me why TSMC is including this in that spec. That's my opinion, and others do share my opinion on this topic.
I actually will agree with you on this one. Early feasibility these days, it's not that simplistic, right? It's a lot more complicated, and I also don't see what part that why is that part of 3D blocks, right? Right. I agree. It's a flow issue, and it's really having the assembly of what chips you have. Kind of is mostly sufficient information from there to set up a flow that will combine all the other the more detailed or less detailed models for the other parts, right? I honestly don't know what to do with a simple a resistance model, right? That really doesn't tell me anything.
Yep, I agree.
Right.
Quite frankly, why is a foundry, providing this or driving this format? I can see for handoff issues, 3D blocks. I mean, it is representing something a foundry would deal with. They have to deal with the assembly and the dimensions of these components. So I think what's in the proper spec certainly makes sense. But
I can venture a guess on this question, right? When you put the chips together, always the first question is, will this work for power and thermal, right?
for what?
For power and thermal, right? Okay, great. We figured out a way we can stack the chips together and put them on a substrate or an interposer. Will this work for power and thermal? That's the first question that will be asked, right? If I'm the engineer who comes up with some kind of floor plan of chips, the first question I will be asked is, will this work for power and thermal? Right. So
I mean, the question is, why does TSMC care about early feasibility?
yeah, I think it may have something to do with the logistics and mechanics about how 3D blocks came about. Right, who exactly created that? It was a designer or an architect. You kind of can see how this stuff will be relevant to them and would like to have that data included. But again, right, I agree that this kind of feasibility stuff, I don't know what to do with it, right? In that format, okay, right. There could be some data, some tool can generate some output, but is that enough? Is it can I be confident enough that this looks good? Probably not. Right. And okay, and then right, but the reason I answered the original question, right? Okay, if there has to be something in the 3D blocks, what should it be, right? And I think transient is more relevant than steady state, especially for power and to some extent for thermal, right? If we're looking at performance.
Yeah, thank you. So by the way, I'll mention that Abhijit Chakraborty from Synopsys, who's responsible for, I think he's responsible for the 3D flow support at Synopsys. He has the same concern. He says, why is this part of the 3D block spec?
Yeah,
So,
so there's several people at Siemens that feel the same way.
so Tony, maybe it would help if this is a concern of yours, then maybe it would help to get with the person at Siemens who comes to the 3D Blocks committee meetings. I think his name is Gary Brist.
Yeah, yeah, I mean, Gary is the guy who I've spoken to, and he's tolerating it, but I don't think he wants to take a strong enough position to say it's not applicable. So he's somewhat ambivalent. He thinks it's not really much value add, but he's not willing to step up and kill it.
Uh-huh.
I think it's relatively straightforward to implement. So if it does become part of the spec, or it isn't a requirement, or it is a requirement by TSMC, we'll support it, but we're not trying to encourage it. Let's put it that way.
Okay.
I guess people are afraid to poke the tiger in the eye.
Okay. But
So,
on the other hand,
that's my personal opinion. It's not the official position of Siemens.
yeah, I understand.
Yeah.
Still,
So
I mean, it seems to me
others
that
may
why
feel we have to do anything that TSMC says. So, I'm not aware of an official Siemens position on this matter one way or another. But
yeah. Okay, I see. It just seems to me though that why be in the TSMC work group if you have concerns and then you're not raising them. But yeah, maybe it has to do with politics associated with
I think it's probably more
relationship to
politics.
TSMC. Okay.
Yeah.
So I thought this was a TDK meeting.
So Tony Bell sent a message that he won't be able to make it.
Okay.
So we are just covering. We're having a free discussion.
Let's see.
Yeah. Yeah. Did you guys see the announcement from ARM that they're joining OCP?
That they're what?
They're joining OCP.
Oh, really?
Yeah. ARM. Oh, okay. ARM has joined OCP. I believe they will be on the board of OCP. And as far as I understand it, they're contributing the CSA, their CSA architecture as open specification to OCP. Actually, probably Russ can tell us the exact mechanics of that. I don't know all the details.
Oh, that sounds like a good step though.
Yeah, so ARM, excuse me, ARM did join the board. They were actually at the board meeting 2 weeks ago. And you can see they should have updated the website by now, I'm sure, showing who the rep was. It's Mohammed, I think. The SCSA spec, we're waiting that contribution. So it hasn't been filed into the contribution hub as of yet. It is in works. And I don't have a date of when we expect to see that.
Okay. Yeah, I think that this is going to be, I'm actually really excited about that, all right, having this open definition, open specification about those chiplet interfaces. I think that's going to be good for the industry as a whole. And that's really important. I know a lot of people, at least in other work streams, have been trying to figure out how do different chiplets will interface each other, what they will be talking, and how they will be understanding each other. And this spec goes a long way towards that, achieving that goal of interoperability. Right, that's the ultimate goal. Yeah, so as I started, yeah, I'm joining OCP. At the Global Summit, there were a couple of companies from the ARM ecosystem who were at the Innovation Village, showing off their chiplet implementations. Global Summit, for those of you who missed it, it was huge this year. I heard 11,000 people attended. I don't know if that's correct, Russ, or if there were more people in the end of the day.
It 11, I think, is the roundup number. I think it was like 10, 8 something.
Okay. Yeah, well, okay, 10,800 people. It was a lot. It was very, very busy. And that was actually very good. One thing that I noticed new this year, apart from ARM, there were I counted. I saw probably a couple of other booths, maybe 2 or 3 booths for chip companies, which is somewhat newish at the Global Summit. Typically, the focus has been on racks, right? Last year was a lot of NVIDIA compute racks, and this year was a lot of focus on power and cooling. It was really mind-blowing to see the 2 megawatt cooling unit. That it was at the Boyd booth. That thing is a monster, and totally impressive with all the pumps and pipes and everything. There was some innovation around supplying high voltage to the compute trays. At the Innovation Village, one of the other sub-projects, they were demonstrating their power plane that can carry 800 volts horizontally and then basically across the entire tray, and then supply 800 volts up vertically, which is pretty cool. Yeah, I was talking to some people outside, and their concern is that at this point, the bottleneck seems to be on the utility side of things. Basically, utility companies want to build very powerful data centers in excess of 300 megawatts per site, and utilities just cannot supply that much power and water to cool it. So, there's a little bit of bottleneck there, right? Because it's a single point on the land that is going to need that much power to come in, right? And utilities are just balking at that, right? So it's kind of interesting.
Yeah. So, David, did you say that the OCP Global Summit had 10,000 people there?
10,800. I rounded it to 11,000, but apparently it's 10,800.
Wow, that's much larger than I thought. That's impressive. How does that compare to previous years? Is it like growing every year?
Oh yeah. Russ, do you know the previous years? I know.
I don't know the exact figure. If I think it was somewhere in the 7K range.
Yes. Okay. I have the same number. So previous
Okay.
year, yeah. Yeah. Okay. So we have the same number. So yeah. So Mark, previous year was 7, and what I heard they were expecting 9 this year, but they got almost 11,000 people.
Okay, thank you.
Yeah, the only way to get to the summit this year, the sensible way was by light rail for me, right? Just because First day I was there early, I was able to park, but we're talking about like 8 in the morning on opening day when all the events were in the afternoon. Next days was impossible to find parking. Right, and it was impossible to find parking, impossible to get coffee. Right, there were like half an hour lines of 50 people waiting for coffee, stuff like that. So that's one thing for next year. We're going to need more coffee stations.
I see.
Apparently, that seems to be consistent feedback year over year. I'm curious. For those that didn't go, why didn't you go?
In my case, I was interested in joining this time, but SI2 had a face-to-face meeting during the same week in Austin, so I was constrained by that.
Okay, anybody else?
Tony is
I
on
had
the
a-
East Coast.
I had a conflict as well, some internal management meetings that I had to attend.
I was just purely curious. I've heard other people give me feedback that the thing's way too large and they don't like large events. So I was just curious considering the conversation.
Yeah. No, it's definitely big, but it was. I honestly I like the breadth of technologies being covered. And especially some of the ideas that people are trying to put down as a real product. There was one company that was doing data storage on a ceramic plate that apparently can last forever, and it's very fast to read, and it's dense enough that you can use it for massive storage, right? These are small ceramic plates. So if we are talking about data that like Library of Congress, for example, put it down on that medium and it's going to last forever. You don't need to read the data, all the time. You just need to retrieve it from timestamp. I think that's awesome. The other thing that was interesting is in one of the cooling. Actually, if you look at the heat exchanger, they have those plates that basically transport heat from the hot pipes to the cold pipes. And then there was very, very interesting demo of a plate that's AI designed. And it has these grooves and ridges and funky shapes that actually can improve the conductivity of of that heat, right? Basically, the dissipation of heat from the one pipe into the fluid and then improve cooling. That looked very impressive. I was wondering what is this piece of copper that's weird like that, right? It has those really weird shapes on it. I thought it's some just demonstration. Somebody was manufacturing copper and they were showing this big slab of copper. But apparently there's a lot more technology beyond that, which it took me some time to understand, but that's what happens with the advanced stuff, right? It takes some time to understand. Yeah. Yeah, but definitely power and cooling was a big topic. Some of the bigger racks were also being demoed. I'm not sure if you guys know. They're trying to change the form factor of the racks basically to be double wide than what it is today, so that they can increase the compute density per rack. It's easier for installation. It's easier for everything. But yeah, pretty impressive stuff. Okay, so I think we're going to have to postpone the TDK meeting to next week. I mean, sorry, into the next meeting, which is going to be in 2 weeks. I don't have enough knowledge to talk about tests. Is there anything else you guys want to cover for today? What else is on your minds?
Hey, David, last Friday during the Chiplet meeting, I was having Windows issues, actually software issues, and I missed the rest of the call. We were talking about the design exemplar that we're doing for the demo.
Yes.
And one of the things we would like to look into is doing a DFT insertion on the design. So
Okay.
We're not sure we have all the cells in the you're still NAM 45, right?
Yes.
Yeah, we're not sure we have all the cells that are necessary to support scan and BIST. So
is there anything specific missing that they should have scan flip-flops?
I don't know. I mean,
Okay.
we have to kind of probably do like it's kind of like a lint or something, but I don't know the details. But Bala would like to kind of run look into it to see load it in and see if we can do that. So I think that would
Okay.
be wow.
Yeah. Bala mentioned that. So I did send him a pointer to where the design files are.
Right. Okay.
We can.
So he has access to the files. I mean,
the whole world has access to those files. I just pointed them where they're.
they do. Okay. Okay.
Yeah.
And the libraries as well. They're in there, or do you have to download those?
The libraries are not there, but I understand that he has access to the same libraries.
Okay. Okay.
Right, because although these are open source libraries, I don't know whether we can distribute them. Right.
Yeah. That's true. Yeah. So so we're we have some internal test cases that we're using to pipe clean our flows.
Yeah.
So typically, if it's just for flow validation, we'll use like a standard technology, TSMC or something.
Yeah.
But for purposes of those and sharing stuff with customers, we're looking at open source. So we ran into some problems, which I'm sure you're well aware of, with ASAP 7. So there is, we are considering funding the development of some of those missing cells, like a basic IO library element,
Okay.
some scan stuff.
Okay.
But because we were not able to do a DFT because of that in ASAP 7. So we found a university that's willing to do the work, and we're just looking to see if we can fund that development, and then we would donate that for open use. So that might be something
cool.
down the road we can do.
Yeah. What technology are you looking at right now, or you don't know yet?
For open source?
Yeah, for that development.
Yeah, I mean, we're getting a lot of people would just prefer to do something a little more modern. So ASAP 7 is the kind of most representative.
Okay. Yeah.
These days, it's not state of the art, but getting into some of these older, 45 and 130 technologies, it's just honestly, it's not a big deal for me, but I guess there's a bit of a stigma.
We had
this
discussion
before.
Yeah. The problem I have with all the other technologies and all the libraries is that say on the standard cells, the characterization was done 15 years ago on the NAND 45, which means that the data in Liberty is at best whatever was common 15 years ago, right? And more modern flows would characterize a lot more data, and libraries are a lot more interesting.
Yeah.
All right. And even actually ASAP 7 has its own little problems with the characterization, right? What's there, what wasn't, because it was done with another company's engine, and every company's engine is going to do what that company needs, right? Not what is best for the whole world, right? So, you know, and I haven't mentioned yet that ASAP 7 has syntax errors in the Liberty files, because I think those were edited post the fact. Some stuff was added post the fact when it ended it with invalid formats.
Right.
Which to me is amazing. Which means any commercial companies tools that parse that and are okay with it. That means that we're all understanding the bugs in the files and kind of trying to work around that, which is crazy. But anyway,
yeah. You know, there are some true open source manufacturable technology. There in 130, there's the 130
these are really old.
Skywater.
Yeah.
And then there's one out of Europe, a company that's a BiCMOS technology. So those are options, but again, that's even, you know, getting older. I mean, we're getting back turn of the century.
Yeah. I think, yeah. I think one thing that is missing is for all these libraries to get a characterization often, right? Every few years, which even if it's 45, right? At the end of the day, for flow demonstration, really what matters is what data is in the libraries, right?
True.
Right. Cells are cells. How fast they are probably to demonstrate the flow doesn't really matter.
Right.
Right. And it would be great if somebody who is characterizing these libraries, if you know, for that to be redone to include all the more common thingies these days, right? Kind of refresh.
Like a great university project or internship kind of internship.
Yeah.
So I mean, right now, you know, our team is small enough. We can't afford to spend that time on that. We're kicking around, maybe setting up a group in one of our offshore facilities that would be able to do this kind of stuff.
Yeah,
because it's important to have these demonstration vehicles to, you know, demonstrate these concepts and not have to deal with all the IP issues. So.
Yes, and I think that's going to be a very, very important step where commercial flows can work and update open source libraries, because really libraries are the biggest bottleneck.
Yeah.
Right. In any development. I think what's going to happen, I hope what's going to happen next is that some of the commercial foundries would start when they offer the libraries, they'll say, hey, here's the open source flow that goes with that, right? And try to see what results you get, right? And kind of get to a more open source world for development, right? Right, the manufacturing stuff is, I understand how that needs to be proprietary, but you know, considering that everybody is excited about chips these days, right? Because of all the NVIDIA and compute and everything, I think that will also add additional, will help, right? I'm sure there's a few board students somewhere that are thinking what to do, and giving them something in their hands to fiddle with. It's going to go a long way, right? That's what we all want.
Yep.
Yeah. Mark, actually, if I remember correctly, non-gate 45 is distributed by SIQ, is it not?
It is. Yes, it came originally from Silvaco, is my understanding, and now SI2 distributes that. There's a um, well, okay, here's how it works. Any person at a university can get it for free from the SI2 download site. And also any SI2 member company can get it for free from the download site. But outside of that, SI2 directs people to get it from Silvaco because Silvaco is the original source.
Okay. I wonder if these guys have rerun, can redo was characterization done at their end as well?
Sorry, you asked if characterization was done at Silvaco. Is that what?
Yes, yes.
I assume so because I believe we just took it as it is. I don't think
Okay.
we've
Okay.
at SI2 have done anything with that library.
Do you think SIQ would be willing to ask Silvaco to recharacterize it again and just dump the just to update the package? Don't touch the cells, don't need to design new cells, things like that. Just recharacterize it so that we get all the latest and greatest properties in Liberty and all the other files.
That's a good question. I'm happy to raise that. I'll bring that up with within SI2 and you're right. It would probably be something that we would then need to request for Silvaco to do. And yeah, I mean, we don't even have the tools ourselves to do that characterization. So, but I'll bring that up.
Yeah, that might be interesting to see.
Okay.
Yeah. Oh, Tony, you guys have all the spice files and everything. Maybe Siemens, right? You guys can think about updating those or releasing the updated Liberty files. Siemens has an engine to characterize standard cells, right?
Yeah. I don't know if it does the characterization or if it just scales it. We have kind of a PBT scaling. That's something that I'm looking into. I'm going to set up a meeting and talk to our team about that.
Yeah. Okay. I think that would be awesome.
I know Magma had a tool back in the day where if you had an existing .lib, you could create a new process corner. They had a flow that did that. But the Solido team, which is really, has a spice engine and a lot of AI stuff built around it, they are doing something about custom .lib creation. But
yeah.
I don't know.
Okay.
I suspect they can. But I don't know. I mean, the problem with the .lib, it's not like you just get a net list of the cell and run spice, right? You need to set up all the scripts that are doing all the characterization. So that I don't know if they have that. They may, but I don't know. Do you have anything at your company?
Me? Only to do 2416, not a full .lib with timing and everything.
To do right. Oh, okay. All right. Okay.
Yeah.
So when you say 2416, how do you generate the 2416?
The cell spice net list and the actually a Liberty file is the Liberty file is an input. And then we can, from Liberty, we can infer a lot about the cells and then run the
Liberty and a net list.
Yeah, the spice net list.
And
a process process models and stuff.
So you need the library with the associated .libs and a netlist for the circuit.
Yes.
Is it the cell based?
Yeah.
No, I'm saying is it for the whole is it for the whole design or just for each cell in the library?
For each standard cell.
Okay, so for each standard cell. So you get a standard cell netlist, spice net.
Yes. And that will generate the standard cell 2460.
2416.
Yeah, and then there's another tool that will generate the design 2416.
So when you say design, you're saying if you have a netlist that uses those cells.
Yeah, we can generate the design.
Right. So you're essentially creating a 2416 library, right?
Yes.
And then you take that along with your top level netlist or your circuit netlist.
Yeah.
Is it Spice or can you do Verilog?
Yeah, it's Verilog.
Verilog.
Top level is Verilog.
The top Verilog, and it can be hierarchical, right?
Of course.
And then you'll create a 2416 model for that.
Yes. Yes.
Okay. Yeah. Okay. And is that how 2416 was that the intent of 2416 or is this a custom tool that you created leveraging that?
2416 is just the model, right? But in terms of intent, I believe that was the intent.
Sorry, 2416. That was the intent. Okay.
Yeah.
Are there tools out there that support that you're aware of?
To read in 2416, yeah.
And create a model for the entire design.
And not create the model for the entire design, just use the 2416 model.
And what do you do when you read it in? What do you do with it?
They do power. We also do power with it.
Okay. Yeah, I'm not familiar with the details of the spec.
Yeah.
Okay. All right.
Yeah. Okay. All right, everyone. Anything else on your minds for today?
No.
Okay. We'll meet again next week. Next week topic is SIPI, and in 2 weeks is going to be a test again. And tomorrow in the design meeting at 9 a.m. Pacific, we can talk a little bit about the design specifics. Okay.
All right.
We are so.
Okay.
Right, everyone.
Thank
Talk
you.
to you next time.
Bye.
Bye.
Take care, guys.